Hello guys, welcome to a new tutorial about the KUKA Sunrise Toolbox. In this tutorial, I'm gonna be speaking about the networking functions that are supported by the KUKA Sunrise Toolbox. So as you see, I have MATLAB opened. Then I'm gonna navigate to the KUKA Sunrise Toolbox folder. Then I'm gonna open the MATLAB client folder. Now copy the path of this folder and change the working directory of MATLAB to the folder MATLAB client of the KUKA Sunrise Toolbox. Hit enter. Now as you can see, the toolbox provides 4 functions for administrating the network between the robot and the computer. So the first function is net establish connection. This function is used to establish a connection between the robot and the PC. The second function is net ping EWA. This function is used to ping the robot. In such a way, you know if there is a network between the robot and the computer. So in order to verify that there is a network between the robot and between the computer, you can use this function. This is used for debugging. This is used for verifying that a network is already there, that the hardware is okay, and that the IPs are in the same range, and that you are connected through a wire between your PC and between the robot. Then you have the net turnoff server. This function is used to terminate the connection between the robot and the PC. Also it is used to turn off the MATLAB Toolbox server application on the robot controller. The fourth function is the net update delay. This function is used to calculate the network delays between the PC and the robot. So right now I'm gonna just verify that there is a network between my robot and between the PC. So first of all, you need to define a variable, call it IP, and give it the IP of your robot. How do you get the IP of your robot? Please refer to tutorial number 1. So the IP of my robot is 172.31.147. Hit enter right now to verify that there is a network between the robot and the PC. I'm gonna use the net ping EWA, and I'm gonna give it the IP as an argument. So as you see here, the robot is pingable and I have 0% loss. So I have a network that is already established between the robot and the PC. So I can go ahead and I can connect to the robot. So you have to start the MATLAB Toolbox server or the touchpad of your KUKA EWA robot, and once you start it, you have 60 seconds to connect to the robot. So I'm gonna type net establish connection, and I'm gonna give it the IP of the robot as an argument, and it's gonna return to me the TCP/IP communication object. So hit enter, and you see that there is a network that has been established between the robot and between the PC. Right now, to calculate the communication delays, I'm gonna use net update delay. I'm gonna give it as an argument the TCP/IP communication object. And what this function is gonna do, this function is gonna give you a plot of the communication delays between the BC and between the EWA. And this function, what does it do? Actually, this function right now is streaming messages to the controller of the robot. Then it waits for the acknowledgement message returning from the robot. And for each message, this function keeps a track of the timestamps. Each time it sends a message to the robot, and using those timestamps, it calculates the delay that is required for sending a message to the robot, then till receiving the acknowledgement from the robot. As you can see here from the plot, the average time required for sending a message then receiving the acknowledgement is 1/234, and it's about 4 milliseconds. And you can see here that the frequency is around 234. Right now, because I am recording this video, actually I got a lower average. Normally it should be around 270 hertz or a bit more. The update frequency of the network, but because as you know, I am recording this video, we got this low number, and at the same time you see that I'm getting some spikes here about 30 milliseconds during the execution, during the streaming, and this is also attributed to the to recording, because I am recording while I am executing the function. Anyway, to get good results, please refer to the tips and the tricks folder of the KUKA Sunrise Toolbox. Actually, I have optimized this computer, this PC, for real-time control, so as to reduce the networking delays. This is easily done in Windows, and I have given the recommendations and all of the steps required to achieve low latency in communication. Again, those tips and tricks, those recommendations are provided in the tips and tricks folder of the KUKA Sunrise Toolbox. Right now I'm gonna close this window, and I'm gonna turn off the server on the controller. Turn off the server on the controller. You have to write net turn off server, and you have to give it the TCP/IP communication object T, and you press enter, and I turned off the server of the KUKA running on the KUKA EWA. So this is pretty much everything about the networking functions that are supported by the KUKA Sunrise Toolbox. Thank you very much for watching.